Today I'm going to talk a little bit about my research in the latest times and what I envision from my results to the future. Well, I'd like to start by asking you a question. What shape would you say a robot should have in a disaster scenario, or if you send them to space where you don't know what they're going to find? Well, it's something to think about, isn't it? But why not rely on someone that answered this a long time ago? That it's nature itself by the clever mechanism of evolution. As humans, we didn't come to the shape at the moment out of the blue. It took millions of years for us to evolve, and with constant interaction to our environment. And the same principle can be applied to robots. At the moment, the current scientists are only doing, when they are doing, some evolution in the controller of the robots in swarm robotics. So I proposed in my researcher the impact of evolving also the shape based on nature. And not only that, but also co-evolving the shape and the controller. Those are some of my results. It's a little bit too much perhaps, but I will guide you through it, don't worry. What you have to focus here is at the end, at the bottom of the graphics. Those are the results that the current researchers have when they don't evolve, they just use the swarm robotics at the moment. This green line shows some improvement already. That's when you have evolution of the controller in a swarm robotics. And then with the technique I introduced, you have evolution of the morphology. You go to this level here. So this is the performance of the swarm, of the group of the robot, and it is drastically improved if you evolve the shape of the robots in the group. And also if you co-evolve them. So based on this research, I believe that aligning it with some high-performance computing and 3D printing techniques that are already available today in the field, you could have robots that could be very groundbreaking and be more real life, evolving like animals do. And for example, in the scenario that I mentioned before, in search and rescue, the robots could be deployed at a place, at a disaster scenario, and evolve and adapt on the go to that situation, giving the victims the best survival chances. As well, using high-performance computing, you could run the genetic algorithm. The evolutionary process could happen in parallel. So this would speed up the process by at least 90%. And this way would give the robots the ability to adapt to unforeseen scenarios. We could then free up some of the controller computation and attribute to the shape, that's the morphological computation concept, and co-evolve the shape and the controller on the go. And the robots would adapt to any scenarios, and also the simulation could be evolved. So what I propose here is I have already done the convolution of morphology, that's the shape, and behavior, that's the controller. Aligned with high-performance computing, you could co-evolve also the simulation. And and this would create robots that would be able to predict their behavior, creating some kind of conscience on robots in ethical sense. That's groundbreaking, and I believe that's the future for robots in general. So thank you for your time.
Thank you very much for your interesting talk. Questions, please.
Okay.
Thank you for the interesting talk. So on your results slide, you had on the vertical axis performance. How is this actually defined?
This performance here,
Yeah.
the robot. In my research, I use the transport scenario where the group of robots need to push a larger object, and it is then given a rate of how well they perform. And you have here the fitness of the robots.
And how well means how far they get?
Yes, exactly.
So
in this scenario.
Each of the approaches then manages to move it at least somewhat.
Yes, at the beginning they can in a swarm, because alone they wouldn't be able to push the objects too large for them. That's why you need a swarm of robots, several little robots cooperating.
Yes. In talking about the ethics that you mentioned as a central future task in this process, there's a discussion in algorithms and in the constitution of algorithms, how the way they repeat inequalities that can be found in the society as they take their data from the society. Can you make a point out of this?
Here, the sense of ethics is in the aspect that robots, anyone that are able to predict their own actions before doing it, they can then reflect and see if it's something right before doing it. So the robots would know, oh, if I go this way, I'm going to hit a human on my way. So I won't go that way. That's wrong. And it would choose another action. And then they would reflect, and you can create some sense of ethics from there.
If I can jump on this, we have known machines that were supposed to work well for everyone. Very simple aspect is the hand dryers in the public toilets. They're supposed to be economic and better for the environment, but they do not recognize black color.
Mm-hmm.
Is your robot gonna recognize people in the same way, or is it gonna discriminate against specific people?
So this is a problem for computer vision. At the moment, the robots are using some vision to differentiate the color of the object. So I'm going to follow the red object or the pink robot or pink target. And this could be some challenge, but the computer vision are evolving as well in their own field. With the prediction of actions, giving this sense of ethics, the robots could also reflect that and predict what is that really the color I'm seeing? In this environment, it's more likely that I see the other color, or I'm seeing all of them are one color. This one is really the same color or not, so it would make them reflect. So this also helps them not to discriminate in trying to improve their actions before committing something that wouldn't be very nice.
Last question. Short answer.
I have a mean one, but...
You have a mean one?
No, maybe if it's more new, then better than mine, because it would
Okay.
be there.
yeah. Maybe a different direction.
Completely other. So in your title, you say self-organized robotic swarms. The name self-organized, I think, comes from a different context and was used before, also distinguished to self-assembled. So what makes your robotic swarms self-organized and not self-assembled?
Okay, actually, in the robotic swarm, it is very common that you use a self-organized term, yes. And this is not the case of self-assembly. The robots, at the moment, they don't attach physically and stay attached. They don't stay assembled. They connect with each other with their physical bodies, but they don't assemble. They organize together.
Thank you very much. So, ready for